This example shows using the control voltage library to generate a envelope and a quantized pitch CV. So again, we're still using the ESP32's built-in DACs, and we'll see that it's not really optimal for quantized pitch because obviously we need pretty accurate voltage to get accurate pitches. And we kind of do okay here. So anyways, just as an example. So the first thing we do is we include the library. We create two signals, one for our quantized CV, one for an attack release envelope, or attack decay envelope, I suppose more properly. Set up our DAC. Now I also did a couple things here. First off, I decided to change the shape of the envelope because I wanted a little bit of an exponential curve to the envelope. So a shape of 1.8 gives us something like this. If we were to increase this, this is basically an exponent. So the higher the value here, the sharper the curve will be. So a sharper curve even there. And you can explore that. If you go below 3, like 0.5, then you'll start to make it be more like a logarithmic curve, which could be nice for some things. We set the bit depth of our system to 8-bit because the ESP32's DACs are 8-bit. And then in here, we're doing three things again. We're running our loop for each of our signals. We have our control loop. And our control loop, we are basically walking through a scale in MIDI notes. And then we're writing those MIDI notes into our CV as MIDI. And this converts it into 1,000 units per volt. So, you know, a value of 1,000 equals 1 octave. I'm sorry, 1,000 units per octave scale. So 1,000 is 1 octave. And then we trigger our attack release envelope with a 5 millisecond attack, a 220 millisecond release or decay. And then in our signal loop, again, we're running at 1 kilohertz sample rate. We're getting those values, and then we're converting the 1,000 unit per octave into 8 bits. So remember, for an 8-bit system, 1 volt is approximately 77 units. But because the DAC on the ESP32 is really not full range or linear, really, I kind of just fudged it. 12 sort of seems like it works okay. And then that just converts that 1,000 volt an octave into a value that's between 0 and 255. And then we write those to our DAC, and we can monitor them in our signal plotter. So let's pull that up. And this is what it sounds like. There's our super plucky envelope. Let's go back to 1.8 for our envelope. One thing that you'll notice is that we're writing a lot of serial data to our serial port. So Arduino can actually start to become unresponsive if you're monitoring too much. It's especially noticeable if you're using the serial monitor, not the serial plotter. But if you close this, then you'll close the serial connection and it'll be sort of no problem. Sometimes you can also find that if you're writing a lot of data to the serial plotter or the serial monitor, it will actually slow down the processing of the microcontroller and affect the frequency. Doesn't seem to be making an impact right now. So again, here we have our red trace is our envelope, our blue trace is our quantized CV. Here we're just using our quantized CV into the 1 volt an octave of the no coast. And then I'm just taking the output of our envelope and directly using it to control the envelope of our oscillator. And it works pretty well.